When connecting two generators in parallel, only one generator needs to be grounded. The reason for this is when two generators are connected in parallel, they establish a shared electrical ground reference. The act of grounding one of the generators provides a common ground potential for both generators as well as the entire electrical system they serve. If both generators were to be grounded, it would effectively create a short circuit. This is because the two ground connections would be directly linked through the generator's internal circuitry. Such a configuration would lead to a substantial flow of current, potentially causing significant damage to the generators themselves. Grounding is a critical safety measure in electrical systems. It provides a low impedance path for fault currents to flow back to the source, allowing overcurrent protection devices, like circuit breakers or fuses, to quickly interrupt the circuit and prevent electrical shock or fire hazard. In a parallel generator setup, a single, well-established ground connection ensures that this safety mechanism is in place for the entire system. If both generators were grounded, it would bypass the intended path for fault currents, compromising the protection scheme. In essence, the single ground point acts as the reference for the electrical potential of the entire system. All other points in the system are then referenced to this ground potential. This helps to maintain a stable and safe operating environment. The selection of which generator to ground is typically not critical. The primary consideration is to ensure that the chosen generator has a robust and reliable ground connection. This connection should adhere to relevant electrical codes and standards, such as those outlined by the National Electrical Code, or NEC. The size of the grounding conductor must be adequate to handle potential fault currents, and the connection points must be clean and secure to minimize impedance. It is important to understand the concept of grounding versus bonding. Grounding refers to connecting a circuit or equipment to the earth, providing a path for fault currents. Bonding, on the other hand, involves connecting non-current carrying metal parts of equipment together to create an electrically conductive path. Bonding ensures that all metal parts are at the same potential, reducing the risk of electric shock. In a parallel generator system, both grounding and bonding are essential for safety. While only one generator needs to be grounded, all metal enclosures, conduits, and other non-current carrying metal parts of both generators, as well as the associated electrical equipment, should be properly bonded together. This creates a unified grounding system that minimizes potential differences and provides a safe path for fault currents. Another important aspect to consider is the type of grounding system used. There are several types of grounding systems, including solid grounding, resistance grounding, and impedance grounding. The choice of grounding system depends on factors such as the size of the generators, the voltage level, and the specific application. Solid grounding provides a direct connection to ground, offering the lowest impedance path for fault currents. This type of grounding is typically used in low-voltage systems. Resistance grounding introduces a resistor in the ground path to limit the fault current. This reduces the magnitude of ground faults, minimizing equipment damage and voltage dips. Resistance grounding is often used in medium-voltage systems. Impedance grounding uses an impedance, such as an inductor, in the ground path to further limit the fault current and control transient overvoltages. This type of grounding is typically used in high-voltage systems. When connecting generators in parallel, it's crucial to coordinate the grounding system with the overall electrical system design. This ensures that the grounding system is effective in protecting equipment and personnel from electrical hazards. It's also important to regularly inspect and test the grounding system to verify its integrity. This includes checking the tightness of connections, measuring ground resistance, and performing ground fault testing. Any deficiencies should be promptly addressed to maintain the safety and reliability of the electrical system. In summary, when connecting generators in parallel, only one generator should be grounded to avoid creating a short circuit. The grounded generator establishes the common ground potential for the entire system. Proper grounding and bonding are essential for safety, and the type of grounding system should be carefully selected based on the specific application. Regular inspection and testing of the grounding system are crucial to ensure its continued effectiveness. Furthermore, understanding the difference between grounding and bonding is crucial for a safe setup. Grounding ensures that there is a path back to earth for fault currents to flow, whereas bonding ensures that all metallic parts are at the same potential difference, thereby reducing the possibility of any shock. It is also very crucial to know the different grounding systems such as solid, resistance, and impedance grounding and understand the correct scenario for where they should be implemented. It is also a very good practice to continually test and inspect the grounding systems, checking for loose connections, impedance, and ground faults, for example.